Back to Mrs. Ogram's Maths. We're going through the worked solutions for one of the D&D resource booklet papers. So thank you to them for allowing me to use their resources in this way and create these worked solution videos for you. There's a link in the video description to their resources, so you can order paper copies of these booklets, which I highly recommend that you do these on paper because of the nature of the maths that we're doing. It's much easier to write out than to do digitally. Okay, so we are looking at the one from the differentiation booklet, which is standard number 91578, and it's practice external assessment number 3. So let's crack on with question 1. So if we differentiate 8x, we get 8. Now 8 over tan x is the same as 8 cot x, and cot is on the formula sheet. That would be, we're going to do it add on for the add that's there, but it'll be 8 times by the derivative of cot x, which is minus cosec squared x. That's in the table that's on your formula sheet. I've written it out in full as I explain it, but you would usually just write it straight away like this as minus cosec squared x. On question 2, we've got a formula for profit that is done in thousands of dollars, and we want to know the rate of its increase at 5 years. So if we are finding a rate of increase, then we need to differentiate. So differentiating that function of p, we've got chain rule on the first bit, so it'd be 3 over 2. Reducing the power of that bracket by 1 takes us to a half. The inside remains as 2t plus 1, and then we times it by the derivative of the inside, where the derivative of that inside bit will just be 2. The e function, the e part itself doesn't change. We have t over 4, or 1/4 of t, and we times it by the derivative of what's inside here, so that if we differentiate 1/4 of t, we get 1/4. Now we can tidy that up and make it a little more useful. So 3 over 2 times the 2, the 2's get cancelled. To the power of a half is the same as a square root. And I'm rewriting it like this because we're going to substitute in a value in a moment, and it's easier to do it like this. That 1/4 t can be written as 1/4 t or t over 4. Okay, so now we want to work out what that rate will be when t is 5. So we're substituting in the value of 5 for t into this, so 2 times 5 plus 1 minus 1/4 e to the 5 over 4. And we will need our calculator for that, so we'll do 3 times the square root of, 2 times 5 is 10 plus 1, so that's 11. Take away 1/4 of e to the power of 5 over 4. That is 9.077, but remembering that we had this in thousands of dollars, so writing this as an answer, so that'll be $9,077 per year is the increase, or the rate of increase. Okay, for part C, we have this function and some information about its tangent. So we're going to need to differentiate it to get the equation of the gradient of that tangent. So if we differentiate natural log, it goes to 1 over the thing that was inside, and then times by the derivative of the inside. So the derivative of the inside in this case is just k. And if we differentiate x squared, we get 2x. Now what we're told is that the gradient of the tangent, or the gradient of the curve, is equal to -4 when x is 3. So if we when x equals 3, we get k over 3k minus 2, minus 2 times 3 is 6. That will be equal to -4. So k over 3k minus 2 will be minus 4 plus 6, so that's a 2. So k will be equal to, if we bring that up and multiply, we've got 6k minus 4. So 4 is equal to 5k. K is 4 over 5, or 0.8. And if you're not confident with your algebra rearranging, at this stage here, you can put that into equation solver on your calculator. On part D, we've got the equation of the curve, we've got a rectangles made within, and we want to find out when the perimeter will be a maximum. So we need an equation for the perimeter, then differentiate it and set it equal to 0 to find a maximum of it. So our perimeter is going to be, well, if this is x and this is y, the x coordinate and the y coordinate, we would have 2 of x and 2 of y to make our perimeter. Now we can't differentiate it as it is because we've got both x and y terms in there. So we need to represent the y in terms of x, which we can do because we've got the formula for how we make y as being the equation of the curve. That y coordinate will be 4 cos x over 2. So if we then did 2 times that, it'll be 8 cos x over 2. Now we can differentiate it. So differentiating with respect to x, we've got 2 plus, well, cos differentiates to negative sign, so this will actually become a minus sign function. The inside doesn't change, but we do need to times by the derivative of the inside, which is a half. So that 8 times a half becomes a 4. Now we set that equal to 0, and we will have 4 sine of x over 2 is equal to 2. So sine x over 2 will be equal to a half. And if we're doing the inverse sine of a half, you should recognize that's on the special triangles. So we can use the one that's a right-angled triangle with side of 1 and 2. Now, if we're doing sine to make a half, we need the opposite over the hypotenuse. So we need this angle here, so that the opposite is 1, the hypotenuse is 2, and when we do sine of this angle, that we get a half. So that angle there on that triangle, it's on your formula sheet. This angle here is pi by 6. So x over 2 is equal to pi by 6. Oops. So x is equal to pi by 3. Now just check back in with the question to make sure we've answered everything. We want the dimensions of the rectangle. So we need the y value as well. So when x is 3, y equals 4 cos of pi by 3 divided by 2. That would be cos of pi by 6. We go back to our special triangle up here. This side here is a root 3. Again, that's on your formula sheet if you need to look up those special triangles. So if we're doing cos of pi by 6, that's the adjacent over the hypotenuse. So that's root 3 over 2. So this will be 4 times root 3 over 2, which is 2 root 3. That is the same as root 12, which is the answer given in the back of the booklet. But it would be better to have it in the simplified form of 2 root 3. Either one, though, is going to get you the correct answer. So if you write 2 root 3, or you write root 12, or you write its decimal equivalent, all of those would be fine. Okay, for part E, we've got something about a rectangular bar of soap, and we're given some things about the dimensions. So let's just draw out what that would look like. So the width is what everything seems to be based off of. So we'll call the width x. Then the length is twice as long, so that's 2x, and the height is half as much as the width, so that's x over 2. Now we're told that it's being dissolved at a rate of 2 centimeters cubed per minute, so we're going to need to think about volume. So the volume is changing at a rate of -2 centimeters cubed per minute. What we want to work out is the rate at which the surface area of the SOAP of bar is decreasing. So we need to work out, if we write down the thing we want to work out, this would be the area over time. Okay, now let's get some formulae for the volume and area. So volume is going to be x over 2 times x times 2x, so that equals x cubed. The area will be, well, if we have the front side of it there, we've got x over 2 times x, and we'll have 2 of them. In fact, yeah, let's do it like that. I'm just going to change that to purple so we can keep track of what's what. Okay, then we'll add on 2x times the height. We'll have 2 of them, so that's this side here. And now we just need to do the top bit, well, which will be the top and the bottom. So we'll do x times 2x and times that by 2. Okay, let's collect all of that up. So this first one here, we've got x squared over 2 times 2, so that's just an x squared. Then we've got, again, the 2's cancel here, but then we get times by 2, so we've got 2x squared. And this final one, we have 2x squared times 2, so that's 4x squared. So altogether we have 7x squared. Now, normally with related rates of change like this, I would go over to the dA by dt and think, okay, how can I use what I've got, which is dV by dt, to make dA by dt? I'd have to times it by dA and divide through by dV, so those two cancel. I'm left with dA by dt. The problem is that finding a link between A and V so I can differentiate it is quite tricky. We don't have a formula where we've got V in terms of A or A in terms of V. We've got this middle ground of X's. So I'm going to use those instead. So this here at the top is not really very helpful. Let's use dV by dx and dA by dx and see where we can get to with that. Okay, so we'll still carry on looking for the missing pieces of the puzzle. So dV by dx, because we've got that, we can easily work out that's 3x squared. dA by dx is 14x. So now could I use those to get a different thing? Instead of dV by dt and dA by dt, let's try dx by dt. So dx by dt, if I start with one of the things that I've got, which is dV by dt, then I can turn it into dx by dt by introducing a dx and dividing by dV. Now that one I can get from this. Okay, so this will be minus 2 times by 1 over 3x squared, because it's the dV by dx flipped over. So again, checking back in with what we're trying to work out here, if I have dx by dt, do I have the other pieces now to make that work? To turn that into dA by dt, I'd need to introduce dA, timesing by dA, and divide through by dx, and look, that's what I've got over here. Okay, so now I can take the next step of saying that dA by dt is equal to dx by dt that we just worked out is minus 2 over 3x squared, and times it by dA by dx, which is 14x. So we've got ourselves an expression for the thing that we wanted to work out, and that's minus 28x over 3x squared, and those x's will cancel, so we have minus 28 over 3x. All right, now back to the question to work out when are we working this out for. So we're wanting that rate when the volume of soap is 50. So when v equals 50, we have, well, the volume is x cubed is equal to 50. So x equals the square root, the cubed root of 50. Which is 3.68. And if we put that into dA by dt, that'd be minus 28 over 3 times 3.68. So popping that in now. We have that the area is decreasing at a rate of 2.53 centimeters squared per minute. Okay, if we are differentiating this function for question 2a, we first want to turn that into powers to make it a little easier to see what we're doing. Ooh, it's a cubed root there, so it'll be to the power of a third. Once it's like that, then you can see that it's a chain rule. So it'll be 1/3, reduce the power by 1, we get minus 2/3 here. The inside stays as it is, and we times it by the derivative of the inside, which is 3x squared minus 1. Don't forget the brackets there. There's often mistakes made here. If we missed that bracket, it would be incorrect because that minus 1 would not be getting times by this thing here. Okay, for part B, we have got the quotient rule. So u equals x squared, v equals log x, du by dx is 2x, dv by dx is 1 over x. So f dash of x, v du by dx, so 2x log x minus u dv by dx. Well, if we do x squared times by 1 over x, that's going to cancel to x, and divided by v squared, so log of x squared. And we want to find when that is equal to 0. So set that equal to 0. Now if we bring the natural log x squared up and times by 0, we're just going to end up with 2x log x minus x is equal to 0. Now let's take out a factor of x. We'll have 2 log x minus 1 equals 0. Now this would give us x equals 0 here. And also 2 log x minus 1 is equal to 0. But if we were to put 0 into this original equation, we would be trying to do log of 0, and you'll see that gives you a math error. You can't do log of 0. So that's an invalid solution. We're going to ignore that one and carry on with this one over here. So log of x will be equal to 1/2. So x is equal to e to the power of 1/2. Now, if you need that in its decimalized form, we can pop that in. That would be 1.65. On part C, we're working out when is this function decreasing, so the gradient will be less than 0. So f dash of x is equal to, well, an e function doesn't change itself, but we multiply by the derivative of what's inside. So that's timesing by 1/2. So this will be a over 2. And if we differentiate minus ax, we just get minus a. We want to find out when that is less than 0 to make that function be decreasing. So we start to rearrange to try to isolate the x term. There we can take the a over to the right hand side. Now we can divide through by a, so we've got 1/2 and 1. Then e to the x over 2 would be less than, if we times everything through by 2, we have this. Now take log of both sides. X over 2 has got to be less than log of 2. and then timesing by the 2, x has to be less than 2 log 2. Now, part D, we've got this toy rocket launching, and we want to find when does it meet the minimum, it reach its minimum height. Now this one, I actually went and checked what the graph looked like for this, because you kind of expect in this context that it would hit a maximum height. But this, I just want to show you the graph, which you could also check on your calculator if you needed to, because sometimes the questions don't go with what your intuition thinks it should be. The graph itself actually looks like, let me show you, see if I can get it up now, this one. So you can see that it actually goes down a bit before it shoots off upwards. So perhaps that's where the whatever is propelling it kicks in. It needs to be launched first and then it boosts upwards. So we're looking for this minimum point just here. Okay, so back to the question then. We've got the equation for its height just here, and to find minimums or maximums we need to differentiate and set it equal to 0. So we have a product rule here for this portion here. When we differentiate the 5, it differentiates away to 0, so we just need to focus on that product rule. So we will do the first part times by the derivative of the second part, which is 1 over t, and then add on the derivative of the first part. So 2 times 0.5 is just the 1, so we are left with a t times by log of t. So just tidy that up a little, and we have 0.5t plus t log t, and we're going to set that to be equal to 0. So if I take out a factor of t, we have 0.5 plus log t is equal to 0. So we can have that t is equal to 0. 0.5 plus log of t is equal to 0. But t being 0 is not a valid solution. We can discount that because we couldn't put 0 into this equation because of that log of 0 happening there. That doesn't work. So carrying on with the other part, we have log of t is equal to minus 0.5. So t is e to the minus 0.5. So over to the calculator, minus 0.5. We have 0.607, and we'll just check we're in seconds. So that will be at 0.607 seconds the rocket touches the minimum of its trajectory. Okay, part E. We're working a least amount, so we're finding a minimum, and it's a minimum of this total length here. So we need to get an equation for the length of that wire. So I'm going to call it L, like it is in the back of the book if you're looking up those solutions, just so I don't confuse things. Now let's take a look at what we've got on the bottom here. So if we call this one x, then this triangle here, the base of that one would be 9 minus x. So using Pythagoras, this hypotenuse here will be the square root of 3 squared, which is 9, plus x squared. And this one on this side is going to be the square root of 5 squared, which is 25, plus 9 minus x squared. 9 minus x all squared. Then L would be to add those two together. So 25 plus 9 minus x all squared. Now, to be able to find a minimum, we need to differentiate this and set it equal to 0. So let's put it into terms that are easier to do that with. So let's turn that into a power of a half. And then this one, this will be, let's expand that bracket. So we have 81 minus 18x plus x squared, so the power of a half. And the 25 plus 81 is going to give me 106. So we can replace that with a 106 just there. Okay, now we can differentiate dl by dx. Well, this first one will be half, 9 plus, oh gosh, here we go, 9 plus x squared to the minus a half, and then times by the derivative of the inside, which is 2x. Then we'll add on the derivative of the other one, so half, again, that gets reduced by minus half there, inside stays the same, and then we times by the derivative of the inside, which is 18 plus, no, it's minus 18 plus 2x. Now I'm going to want to set that equal to 0, but before I do, I'm going to tidy it up because that's not going to be easy to work with algebraically as it is at the moment. So this top bit just here, the 2's cancel out. We've got an x on the top over a square root of 9 plus x squared. So that'll be x over the square root of 9 plus x squared. Then the second term, we've got the minus 18 plus 2x here. It gets divided by 2, so that'll be 2x minus, oh wait, gets divided by 2, so it'll be an x minus 9, and I'm just writing it that way round rather than minus 9 plus x because I don't like it starting with the negative. On the bottom we have it's over the square root of x squared minus 18x plus 106, again just putting it in the order that I like having the x squareds at the front. Doesn't really matter too much though. We're going to set that equal to 0 now. Okay, now let's carry on and solve it. So bringing the x minus 9 fraction over to the right, so I'm going to move that over to the right. We will have x over the square root of x squared plus 9 will be equal to minus x minus 9 over the square root of x squared minus 18x plus 106. Okay, I'm just going to sort out this minus here. So that would make it a minus x plus 9 if we remove the brackets, or 9 minus x. Okay, now bring this up to that side and multiply this up to that side and multiply. So we'll have x times the square root of x squared minus 18x plus 106 is equal to 9 minus x times the square root of x squared plus 9. Ooh, okay, some tricky algebra that we're dealing with here. Now we want to square each side to get rid of the square roots. That means the outside has to get squared as well. So that x became x squared. The 9 minus x needs to be squared, and then times by the x squared plus 9. Okay, now we've got x to the 4 minus 18x cubed plus 106x squared. If we do 9 minus x squared, we will have 81 minus 18x plus x squared times by x squared plus 9. So that's 81x squared, 18x cubed, x to the 4 plus 9 times 81 is 729 minus 9 times 18 is going to be 162x plus 9x squared. Now, helpfully, there's some pieces on there that already cancel out on both sides, so we can cancel the x4s. We've got a minus 18x cubed on both sides, like this. And now we can collect up the quadratic that's left, bringing it over to the left-hand side. So if we've got 106x squared and we take off 9 and 81x squared, so we go 106 minus the 81 and minus the 9, we're left with 16x squared. The x term, we've got minus 162, so bringing it over to the left makes it plus 162x. And then the constant we've got 729. Bringing it over to the left, we make it a negative and set that equal to 0. Now that is not one that I can see an easy factorization for, so let's go to equation solver, and we're doing a polynomial. Wait, pressed the wrong one. There we go. Polynomial with degree 2. We've got a is 16, b is 162, and c is minus 729, and solve it. So we've got x equals 3.375 or minus 13.5. Well, in this context, a negative number doesn't make any sense. It's got to be positive because this is the value of x. Remembering that we're looking for how far that anchor point has to be from the short mast, so how far from the left. We're looking for that x value just here, so it's got to be this one. Okay, so x equals 3.375 meters from the shorter mast. Pop that all onto one screen so you can see the full solution all together. Now let's move on to question 3. Before we differentiate this, let's just turn it into an easier power form like this, so it's inline. Right now, if we differentiate dy by dx, we bring down the 3 and times it by the 6, we get minus 18. The power reduces by 1, the inside stays the same, and then we times it by the derivative of the inside. So that will end up being minus 36, 2x plus 1 to the minus 4, or that could be written as minus 36 over 2x plus 1 to the 4. Any of these 3 lines would get you the mark. Okay, part B. We've got a function y is tan x, and we want to show that this thing here is true, so we're going to need to find the pieces of that and substitute it in. So if we start with dy by dx, well, if we differentiate tan x, we get sec squared x. We will also need the second derivative. So if we differentiate sec squared x, we need to think about this as being like saying sec x squared. So it again is a chain rule. So it's 2 and reduce that power by 1, leave the inside alone, and then times it by the derivative of the inside. Well, sec differentiates to sec x tan x, and that's on your formula sheet as well. So this is going to be 2 sec times sec is sec squared, and then tan x. Okay, so dy by d2y by dx squared, going back to this bit here, we're trying to show this equals 0. We're going to take away 2y dy by dx is going to be equal to, so d2y dx squared is the 2 sec squared x tan x minus 2 times y, which is tan x, times by dy by dx, which is sec squared x, and now you can see those two things are the same. 2 lots of sec squared x times tan minus 2 lots of sec squared x times tan, that equals 0. So we're doing parametric equations for part C. So we need to differentiate dx with respect to t. So, well, x is equal to 2 times t minus 1 to the minus 1. So I'm just trying to fit that in up there. So if we were to differentiate that, it's a chain rule. So it's minus 2 t to the minus 1 to the minus 2 times by the derivative of the inside, which is 1. And then dy by dt. If we differentiate sine, we get cos. Inside stays the same, but we need to multiply by the derivative of the inside. So multiplying by a half, 4 times a half is 2. So dy by dx is dy by dt times dt by dx. So dy by dt was 2 cos of t over 2 times by, we need to flip over the dx by dt. So let me just move this out of the way a little bit, show you what I'm doing up here. Okay, so this is minus 2 over t minus 1 squared. So if we times by dt by dx, we flip that over, it's t minus 1 squared over minus 2. And we're doing that when t is equal to 4. Okay, so this will be 2 cos of, well, 4 divided by 2 is 2. 4 minus 1 is 3, so that'll be 9 over minus 2. And let's pop that in. So 2 cos of 2 times 9 divided by negative 2, 3.75. For part D, we've got a rate of change question. So let's look at what we're being told. We've got a rate here of the water's going in at a rate of 280, but leaking out at a rate of 40. So overall, our volume is changing. So the rate at which the volume is changing is to have a plus 280 and then a minus 40. So overall, it's going to be increasing by 240 centimeters cubed per second. The other place where a rate is spoken about is here, the rate at which the height of the water is changing. So that's the rate we want to work out. So dH by dt is the thing that we want. So it's good to keep an eye on that. We're also told some information that links the radius and the height. So I'm going to label the height here as h. The radius is equal to 1/3 of the height. Now we want to start with the thing that we know about, which is dV by dt, and turn it into the thing that we want. So let's think about how to make that happen. So if we start with dV by dt, we'll need to introduce dH, so we need to times by dH. We need to get rid of the dV, so we'll divide by dV. Then the v's would cancel, we'd be left with dH by dt. Okay, so we've got dV by dt, we need to work out dH by dV, which means we need a formula that links the volume and the height. So if we can find volume in terms of h, then we can work that out. So the volume is going to be pi r squared times the height. Well, r we can write in terms of h, so this will be h over 3 squared times h. So this is pi h cubed over 9. So dV by dH, if we differentiate that now, we will have, we'll bring the 3 down. So it's 3, oops, I missed the pi, 3h squared over 9, which simplifies to pi h squared over 3. So then going back to dH by dt, that we want to work out, it will be dV by dt, which is 240, times by dH by dV, which is this thing flipped over, so 3 over pi h squared. Now we want to do this when the volume, let me just get my highlighter here, when the volume of water in the container is 500. So when V is 500, going back to our volume formula, this here will be equal to 500. So pi h cubed over 9 equals 500. So we do 500 times 9 divided by pi, and then we'll do the cubed root of that. So h is 11.3. So dH by dt will be 240 times 3 over pi times 11.3 squared. And that is 1.8. Now what are we measuring in? We are doing, the height is in centimeters and the rate that it's changing is every second. So that'll be 1.8 centimeters per second. Okay, last one for this paper, part E. Let's start by differentiating y. This can be rewritten as 3, 4x plus 1 to the half. So dy by dx is a chain rule. Half times 3 is 3 over 2. 4x plus 1 to the minus a half, and then times by 4. So the 4 and the divide by 2 cancels, so that'll be a 6. I'm actually going to write that as being 6 over the square root of 4x plus 1. I think that's going to be easier to work with as a gradient in the functions. What we need to work out is the equation of this line, so we can set it equal to the equation of the curve and find where they intersect for point P. So the equation of the straight line is y minus y1 equals mx minus x1. We have a coordinate on the curve which is minus 4, 0. So y minus 0 is equal to mx minus 4. So that gives us y is equal to, well, the m is the same gradient as we have here. So we can call that 6 over root 4x plus 1 times by x plus 4. So that equation is going to be 6x over the square root of 4x plus 1 plus 24 over the square root of 4x plus 1. Which actually probably makes more sense to put it all over the same denominator of 4x plus 1. Okay, now that's the equation of the straight line. We want to set it equal to the equation of the curve, which is 3 root 4x plus 1. So we can find when those two lines intersect. So next we can go 6x plus 24 will be equal to 3 times 4x plus 1, because what I've done there is bring that up in time, so the square roots cancel each other out. So we have 6x plus 24 is equal to 12x plus 3. So 6x is 21. X will be 21 divided by 6, which is 3.5. So that gives us the x coordinate here is 3.5 for P. We need the y coordinate also. So y will be 3 times the square root of 4 times 3.5 plus 1, just putting it back into our y equation up here. So that will be, let's go times by 4, add on 1, square root it, and then times by 3, we've got 11.62. So the coordinates of P are that x is 3.5 and y is 11.62. And we are done with another paper. If you found that helpful, please like and subscribe. It helps others to find it too. Check out the other videos that are on my homepage, and I'm sure you'll find some more useful stuff in there as well.